Hey everyone, and welcome to The Explainer. Okay, today we are diving into the absolutely fascinating evolution of Arduino. We're going to trace its journey from, honestly, a kind of quirky idea born near a local Italian bar, all the way to the absolute powerhouse microcontroller that's driving so many of today's complex electronics projects. Let's get right into it.
To kick things off, let me ask you a slightly unusual question. What do an 11th century Italian king, a local pub with cobblestones outside its door, and a modern 3D printer all have in common? I know, it sounds like the setup to a pretty strange joke, right? But it's actually the literal origin story of a movement that completely democratized electronics and hardware engineering as we know it today.
So the story takes us back to 2002 in Ivrea, which is this picturesque town in northern Italy. Massimo Banzi was teaching at the Interaction Design Institute there, and he had a major problem. He needed a way to teach his design students, people with absolutely zero electronics experience, mind you, how to build interactive projects. So he set a strict goal for himself. He wanted to create an affordable, plug-and-play board that cost about the same as going out for pizza, so around $30. And well, the result was this somewhat crude but totally revolutionary early prototype you're seeing right now.
Section 1, The Underdog King, Arduino's Origins.
Now, you might be wondering about the name. Arduino didn't come from some dry tech manual. The project was actually named after the Bardi Re Arduino, the local watering hole where Bonzi and his friends would go grab a drink. And that pub itself, it was named after King Arduin, an underdog Italian ruler from way back in the year 1002. Bonzi actually hit the nail on the head regarding the philosophy of this project when he said, 50 years ago, to write software, you needed people in white aprons who knew everything about vacuum tubes. Now, even my mom can program. See, it wasn't about making a tool for hardcore engineers. It was about giving everybody a seat at the design table without needing to learn terrifying algebra first.
Section 2, Democratizing Hardware, a $30 Revolution.
Before Arduino came along, the go-to tool for this kind of work was usually the basic stamp microcontroller. But man, the old way was expensive. You'd often end up dropping around $100 once you added in all the necessary extra parts. Plus, it was super complex and mainly built for Windows. The Arduino way completely flipped the script. They brought the cost way down to $30, threw it a USB cable, and made it plug and play right out of the box for both Mac and PC. Literally no extra programmers required. A real game changer.
Section 3, Meet the Mega 2560 for complex projects.
But hey, we aren't just here for the history lesson, right? We are here to talk about the heavy hitter in their lineup. This is the Mega 2560 Rev 3. While the original Arduino Uno design was fantastic for simple projects, the Mega 2560 was created to replace the older Arduino Mega. It is the highly recommended powerhouse designed specifically for handling complex robotics and the intense processing needs of 3D printers, like the MakerBot Thing-O-Matic.
Section 4, Power and Memory, AT Mega 2560 Specs.
So if you're building a robot, you really need to understand the AT Mega 25060 microcontroller driving the whole system. The absolutely crucial point regarding power is managing your voltage correctly. The Mega can be powered via a simple USB connection, an AC to DC adapter, or even a battery. But look at these limits. The recommended input is between 7 and 12 volts. If you drop below 7 volts, the 5-volt pin might output less than it should, which basically makes your entire board incredibly unstable. On the flip side, if you push it past 12 volts, inching toward that absolute limit of 20 volts, you risk totally overheating the voltage regulator and frying the board. So definitely stick to that 7 to 12 volt sweet spot.
All right, let's talk storage. The Mega gives you an impressive 256 kilobytes of flash memory to store your code. Now, 8 kilobytes of that are reserved just for the bootloader, but that still leaves you with a massive 248 kilobytes strictly for your project sketches. And let me tell you, in the world of microcontroller programming, that is a vast playground. Rounding out the memory stats here, we have 8 kilobytes of SRAM and 4 kilobytes of EEPROM. That EEPROM is super handy, by the way, because you can read and write to it using the EEPROM library. And pulsing behind all of this, the 16 megahertz crystal oscillator. Think of it as the steady, racing heartbeat that times all of your complex operations.
Section 5, I/O and Communication, Connecting the World.
Now, an Arduino is pretty much useless if it can't send, talk to the outside world, right? And this right here is exactly why the Mega is the king of the hill. 54. That is the number of digital input and output pins you have at your complete disposal on this board. Just to put that into perspective for a second, that means you can independently control 54 separate LEDs, motors, or sensors all at the exact same time. Each one of those pins operates at 5 volts and provides a recommended 20 milliamps of direct current. But heed this warning carefully. Do not exceed the 40 milliamp absolute maximum limit on any single pin. If you do, you risk doing permanent damage to the microcontroller, and nobody wants that. Oh, and additionally, the Mega packs in 16 analog inputs, each offering 10 bits of resolution. That means it can read 1,024 different values of whatever you're measuring, whether that's light, temperature, you name it.
So the crucial takeaway here is that not all pins are created equal. As you can see, the Mega features 4 hardware UARTs for TTL serial communication. Basically, it can talk to 4 distinct serial devices simultaneously. It also has 6 pins dedicated specifically to external interrupts, and 15 of those 54 digital pins can provide 8-bit PWM or pulse width modulation output. And finally, you've got dedicated pins for SPI and TWI communication, giving you pretty much endless ways to connect to other chips and shields. The whole shebang.
Section 6. Programming and Action. Uploading your code.
Okay, so how do you actually get your brilliant ideas onto this beautiful piece of silicon? Well, thanks to that original mandate from Massimo Bonzi to make things as easy as possible, the process is incredibly straightforward. Step 1, you just connect it to your Mac or PC via USB. Step 2, you write your code using the intuitive Arduino software, the IDE. And step 3, just hit upload. Because the AT Mega 2560 comes pre-programmed with a bootloader, it communicates using the original STK500 protocol, meaning you do not need any external hardware programmer to push your code to the board. It's just that simple.
Also, I have to mention there is a tiny unsung hero on this board, the built-in resettable polyfuse. Look, if you accidentally cause a short circuit or draw more than 500 milliamps, this little fuse automatically breaks the connection. Even though most computers have their own protection these days, this adds a vital extra layer of security. It basically safeguards your expensive laptop's USB ports from, our messy soldering mistakes. We've all been there.
Section 7. The Maker Revolution. Global Impact.
Let's zoom out for a second. What started as an experiment, handing out just 300 blank boards to design students in Italy, has absolutely exploded. Today, they manufacture anywhere from 100 to 3,000 boards a day at a facility near Ivrea. And they've developed this rigorous custom testing system for all those dozens of pins, which actually ensures a failure rate that stays well below 1%.
The global adoption has been staggering. Way back in 2011, they had already sold over 250,000 official boards. And honestly, that number doesn't even account for the countless open-source clones out there. Top-tier universities like Stanford and Carnegie Mellon use them in their classes. Google even released an Arduino-based Accessory Development Kit, or ADK, which allows Android phones to interact directly with motors and sensors.
I think the true power of Arduino is best summed up by lead software developer David A. Mellis. He notes that Arduino isn't about dumbing down engineering, and it's certainly not about replacing the professional engineer. Instead, it allows artists, designers, and hobbyists to build a prototype and just say, hey, this is what I want to do. It's really about facilitating collaboration across completely different disciplines.
Which brings us to our final slide today, and a question I really want to leave you with. From a local Italian pub to literally powering 3D printers, the barriers to electronics and programming have been completely removed. You have a massive 54 I/O pins, 256 kilobytes of memory, and an entire global community backing you up. So, now that you have the specs and the story, what incredible project are you going to bring to life with the Mega 2560? Thanks so much for joining me on this explainer, and I will catch you on the next one.